Good evening. Today we'll be discussing a pulley system, and we all know what a system is, and we all know what a pulley is. And basically, a pulley is considered as a machine, and what it does is that it enables us to apply a small effort to overcome a very large load. So now this is what the pulley does, and when you have a very large load, now when you apply a small effort, this pulley system enables you to be able to overcome a very large load using a small effort. Now the diagram of a pulley system is giving us where this is the load, and this in this direction we apply the effort. So we know that this load has a mass of m. And what is a weight? A weight is a force that acts on the mass. So now it shows that there is a force which is the weight, and it's giving us what? Mg, where m is the mass of this body and g is acceleration due to gravity. So now as a result of this mass pulling the body down, this string experience what? A tension T. So now when you apply the effort in this direction, in this downward direction, now the load, as the case may be, is considered to move up by an acceleration of a. So this tension here, this rope here experiences a tension T, provided that this string is inextensible. Hence the tension at this extreme of the load is the same as the tension at this extreme of the effort. Therefore, we can recall from the equation, Newton equation, that the net force is equals to mass times acceleration. So now when you look at this point here, the weight is the force acting downward and the tension is the force acting upward. Therefore, we can now take the net as the difference between the tension and the weight mg to be what? Equal to what? Mass and acceleration. So we can now make T the subject of a formula, that is make T to stand alone. Then we take mg to the other side. We have m a plus mg. Now when we factorize, the tension is equals to what? M open brackets a plus g, close the brackets. So now this equation is basically used to calculate the tension at what? At the inextensible string. So now from there we can now calculate the acceleration as what? As a is equals to the net force over what? M, where the net force is equals to the tension minus ng. Therefore, acceleration is equal to what? The tension minus mg over what? Over m. So now after calculating the tension using this equation 1, 2, you cannot substitute the tension into this equation, subtract it from the mass to divide it by the mass. Sorry, subtract it from the weight, divide it by the mass to have the acceleration, where g is equals to 9.81 meter per second squared. The mass is given here, and the tension is calculated from this equation 2. Therefore, we can use equation 3 to calculate the acceleration of this body when the effort is being applied at this extreme. So now